We're going to be talking about polar coordinates, and this first piece should be somewhat of a review as you learned about polar coordinates in trig. If you remember, with polar coordinates we have r and theta, and we plot them on polar graph paper. The center of the graph is called the pole, and then angles are measured from the positive x-axis, and we go around counterclockwise for positive angles. So if we had the point r theta, r being the radius and theta being the angle, so I'm going to swing around counterclockwise, find the terminal side pi over 4, and then I'm going to count out 5 and put my point. Now, if it were a negative angle, as we did with trig, we would measure it clockwise. So I would go around negative 3 pi fourths, make my terminal side, and then count my radius of 3 and put my point. If I had a negative radius, I go around and find the angle's terminal side, but then instead of counting out on that terminal side, I actually go back on the other side of the pole for a negative. So I go back this way and I count 4 and I put the point. So if I had the point 7 pi and pi halves, I would go to pi halves, I would count out 7, and there's the point. If I had the point negative pi halves and then negative 7, I would count back the other way, negative 7, and I would end up in the same place. If I had the point 7 and 5 pi halves, I would go around once and then around again, and I'd end up at the same place as pi halves, count out my 7, end up in the same spot. And if I had negative 3 pi halves, I'd go around the negative direction, count out 7, end up in the same spot. As you can see, unlike rectangular coordinates, the way to list a point is not unique. Here are 4 ways to list the same point, and there are an infinite number of ways to list the points, so they are not unique. Now let's look at our connection between rectangular coordinates and polar coordinates. If we have the point xy in our rectangular coordinates, we can make the r and the theta, and we can make a triangle here, and then using trig we would get our connection between the two coordinate systems. So as we look here, first of all, with Pythagorean theorem, we know that x squared plus y squared equals r squared, so we could solve for r and have a connection between r and xy. R equals the square root of x squared plus y squared. Then, if we use trig functions, we can relate the angle theta to x and y. Tangent theta is opposite over adjacent, so y over x. And so theta would be the inverse tangent of y over x. So rather than memorize these, you may get them memorized in using them, but it's really easy to just draw a triangle, label it, and use Pythagorean theorem and trig functions tangent to get the connection between the two. Now, if we also look at that triangle, we can connect just x with theta and r, because cosine theta is adjacent over hypotenuse, and we could solve this for x. So x would be r cosine theta. So we have a connection with just the x variable to the polar world. We could similarly look at sine theta, which is opposite over hypotenuse, and so that would be y over r, and we could solve this for y, and y would equal r sine theta. So here's our connection between rectangular and polar coordinates. Now, if we wanted to convert a rectangular coordinate system equation to a polar system equation, then we could use that connection. First of all, if we look in the rectangular and have x squared plus y squared equal 9, we recognize that as a circle centered at the origin, having radius square root of 9 or 3. And if we were wanting to graph that same thing in the polar world, to get a circle, we essentially need to go out 3 and cover all angles. So we could actually just write that as r equal 3 by not mentioning theta here. Theta can take on all values, and so if we went out 3 and we took on all values, we would get a circle of radius 3. So there's the two different ways to think about those. If we actually wanted to do the conversion, we could use our connection. If we square rooted both sides here, we would have 3 equals the square root of x squared plus y squared, and if we remember, that was r, and so we indeed get r equals 3.